This section will present details on data cleaning and how to use statistical methods for data preprocessing. Data cleaning is a key step to preprocess the data. Missing value is a common feature of data collected in almost all research and can have a significant effect on the conclusions that can be drawn from the data. It refers to the data value that is not stored for a variable in the observation of interest. In addition, data noise cannot be avoided in most of cases of data analytics. This refers to a large amount of additional meaningless information. Random noise is often a large component of the noise in data. Obviously, it is imperative to deal with missing values for the following reasons. Missing values are generated by collection errors or missing observations, which is difficult to avoid. Missing values are the most common problems in data analytics. When missing values come out, certain model performance is decreased since missing values will lead to model bias. Even for models that can handle missing values, they might be sensitive to it. Moreover, the model performance will be reduced with the increment of missing values, such as data analytics on streaming data. Typically, we can process missing values with methods including deletion, dummy substitution, mean substitution, frequent substitution, and regression substitution. We will introduce these methods. Before that, you can observe various cases of missing values from these figures. As shown in this figure, we can delete the rows with most missing elements. Generally, we can set a threshold for the ratio between number of missing elements and number of elements for a certain row to implement deletion. For the categorical attributes of features, we would use unknown to replace missing values. In other words, we introduce additional attribute values, which will not significantly affect model performance if missing values don't dominate these attributes. In addition, we could use the most frequent attribute value to replace the missing values for the categorical attributes. For example, missing values of the attribute entry can be filled out with most frequent item, chicken. For continuous attributes, we can use mean of attribute values to replace the missing values. Take the attribute age as an example. We use the mean value 48 to replace the missing values for these attributes. Moreover, we can employ regression methods such as ARIMA to estimate the missing values if we have attributes with time series features. In addition to missing values, outliers are another challenge to data preprocessing. Outliers is very common in multi-dimensional data, such as high-dimensional data. Outliers would distort the models, which will decrease model performance significantly. For example, outliers will reduce the clustering performance with k-means clustering method. Some models, such as k-means clustering methods, are sensitive to outliers. However, sometimes outliers are the interesting data points. For example, streaming data will introduce challenge on judging outliers, since some outliers will be a clue for detecting concept drifts. For example, credit card fraud detection alerts purchases that fall outside a customer's usual purchase pattern. Some tools will help detect outliers such as scatter plot and box plot. Additionally, we can process outliers with methods such as trimming and replacement if the outliers can be recognized accurately. Data normalization is a process in which data attributes within a data model are organized to increase the cohesion of entity types. In other words, the goal of data normalization is to reduce and even eliminate data redundancy. There are two primary advantages of having a highly normalized data schema. Increased consistency. Information is stored in one place and one place only, reducing the possibility of inconsistent data. Easier object-to-data mapping. Highly normalized data schemas in general are conceptually closer to object-oriented schemas because the object-oriented goals of promoting high cohesion and loose coupling between classes result in similar solutions, at least from a data point of view. Downsampling is the process of reducing the sampling rate of a signal, which is an effective way to handle imbalanced data. Thank you.